Welcome to section 5.5, absolute value inequalities. Today we're going to solve and graph absolute value inequalities. So consider the absolute value of x as less than 5. What numbers would be solutions to this? Since we want to be less than 5 and we're looking at absolute values, we're looking at numbers that are between -5, not including -5, so like -4, -3, all the way up to like 3 and 4. But not up to 5. So we could have like 4.9. Those are the absolute values that are less than 5. And if we graphed it, since we have the less than symbol, we would have open circles at -5 and 5. So we'd have open circles there, and we would connect them. Everything between those two numbers works, up to but not including -5 and 5. And if we had to write the compound inequality of this, this is two numbers connected by a bar. This is a compound and. So -5 is less than x is less than 5. So if we have a less than symbol, it is a compound and, always. And we would write them as a compound and all together, like such. So anytime we see an absolute value is less than a number, it is a compound and inequality. When we solve absolute value inequalities, we solve them just like absolute value equations with one minor difference. We have to set up two inequalities like we've done in the past for equations. So x minus 3 is less than 5. And it's an and. But when we set up our second inequality, since we're changing our 5 to a -5, it's like we're multiplying that side by a negative number. So we need to flip the inequality to a negative. So we have x minus 3 is greater than -5. This is my setup. We solve both. We have x is less than 8. And x, add 3 to both sides, is greater than -2. So our inequality itself is -2 is less than x is less than 8. And when we graph it, we have -2, we have 8, we have open circles because there's no equal bar, and they are connected by a bar, like so. If it's easier for you to graph it first, you can graph it and then write the inequality off of your graph. This says x is greater than -2, which shows that with our coming in from the left. We have x is less than 8, which is what shows on the right, and they are connected. This is solving an absolute value inequality with a less than symbol. They are compound and inequalities. Now we have to consider absolute value of x is greater than 5. And what numbers would be the solutions for this? Well, we want to have absolute values that are greater than 5. So we need numbers that are like 6 and 7 and going up. We also can have negative numbers like -6, -7. Because the absolute value of -6 is +6, which is greater than 5. Our graph for this would look like so. We'd have a 5, we'd have -5, we have open circles again still. But now we need numbers that are less than -5, because -6 and -7 are less than that. Numbers greater than +5 to the right. This is what our graph would look like. And we would write the solution as x is less than -5, or x is greater than 5. So whenever we have the greater than symbol, we have a compound or. It's going to be one or the other. So whenever you have absolute values that are greater than a number, they become compound or inequalities. So we have two different inequalities we are going to solve. The one on the left, as you notice, has a greater than symbol. So we should know just by looking at this, this is a compound or. We're going to set up our two inequalities. Y plus 4 is greater than 12. Y plus 4 is less than -12. And again, we have multiplied by -1 to the 12, so we have to flip that inequality around. Then we are going to solve both inequalities by subtracting 4. We have y is greater than 8. Or we're going to subtract 4. Y is less than -16. This is my inequality. And this is my graph. We have negative 16 here. We have 8. I'll throw a 0 in there also. And we are greater than 8. So we're going to the right. We are less than negative 16. So we are going to the left. There is my graph. There is my solution. For number 2, we see it has a less than or equal to symbol. This is going to be a compound and inequality. So we're going to set them up. We have y minus 1 is less than or equal to 8. And y minus 1 is greater than or equal to negative 8. And again, we flip the inequality and we solve both. We add 1. We get y is less than or equal to 9. And y is greater than or equal to negative 7. If it helps to graph them first, you can. And we have negative 7. We have 9. Our y is greater than or equal to negative 7. It's got a closed circle because the equal bar. And we're going to the right. We have y is less than or equal to 9. We have a closed circle. And we are connected by a bar. And our inequality is negative 7 is less than or equal to y is less than or equal to 9. There is my compound inequality. And if it does help you to graph these first, you can do that. You don't have to graph them first, but sometimes it might make it easier to see what's going on and how to write your inequality. Here we have a few more complicated problems. The one on the left, we have a 3x minus 4 in the absolute value bars. It's greater than 12. Since we have a greater than symbol, we should all know right now that this is a compound OR. We will set up our two inequalities. 3x minus 4 is greater than 12, or 3x minus 4 is less than negative 12. We solve both of them. We're going to add 4. And I do that to all of it right away. Multiple solvings at the same time. 3x is greater than 16, or 3x is less than 8, negative 8. Divide by 3. We're doing two different inequalities at the same time. We have x is greater than 16/3, or x is less than negative 8/3. We would graph these. And negative 8/3 is the same as negative 2 2/3, just so you know. Here's negative 2 2/3. We have 16/3, which is 5 1/3. Sometimes when you have fractions and you're working on a number line, you will want to change them into mixed numbers so you can see where they sit between different numbers. And we have x is less than, so we have an open circle. We're going left because we're less than. We're greater than, so we have an open circle going to the right. And this is my inequality with its graph. Okay, the last one is the most complicated of all of them. And remember when we did equations, whenever we work with absolute values, we have to isolate the absolute values first. This is the same thing that we have to do with inequalities. Just like equations, we have to isolate first. So all the problems we've worked before have had the absolute value isolated. So we need to isolate first. So the first thing I'm going to do is add 8 to both sides. Then we have 7, 3y minus 4 in the absolute values is less than or equal to 56. Then divide by 7 to get the absolute value by itself. We have 3y minus 4, which is less than or equal to 8. Now that the absolute value is isolated, we can set up our two inequalities. And again, this is a less than or equal to, so this is a compound and. So this is less than or equal to 8 and 3y minus 4. We have to flip the inequality, greater than or equal to negative 8. And we solve. We add 4s. I'm going to solve both at the same time here. We have 3y is less than or equal to 12. And we have 3y is greater than or equal to negative 4. And again, this is an and. Divide everything by 3 on this one. Divide by 3 on the one on the right. And we get y is less than or equal to 4. And y is greater than or equal to negative 4/3. So I'm going to go to the top to graph it. We have negative 4/3, which is the same as negative 1 1/3. We have a 4. We are less than or equal to 4, so we have a closed circle going left. We have greater than or equal to negative 4/3, and we have a closed circle going to the right. And we would write this inequality as negative 4/3 less than or equal to y, which is less than or equal to 4. There's my graph. There is my inequality. And with compound ands, they must be written as one inequality. I do not want to see that and written in there. They need to be written as one compound inequality. All right. Now we have another part that we have to talk about is writing absolute value inequalities from a line graph. There are two parts we need to do. And remember what we did when we graphed absolute value functions will help understand how this is done, I think. Here we have a number line with x is less than 1, less than or equal to 1, and x is greater than or equal to 7. This is an or inequality because we have a gap in between. So it's either less than or equal to 1 or it's greater than or equal to 7. To write an absolute value, we need to figure out where our middle point is, and we need to figure out how far away from the midpoint we are. So the first thing I'm going to do is find the midpoint of the graph. And to find the midpoint, it's actually pretty simple. You take the two endpoints here, 1 and 7, you add them together and divide by 2. So we get 8 divided by 2, which is 4. That is my middle point. The other thing we need to find is the distance. So we know our midpoint's right here, and we need to find our distance from the midpoint to our endpoints. Now this one you can actually see if you go from 4 to 7, it's 3. From 4 to 1, there's 3 units in between them. Another way to do this is if you don't have something you can look at like this really easily, is you can actually find the distance from the midpoint by doing a really quick mathematical formula. So our distance between our endpoints is just the endpoints subtracted from each other. So we take the absolute value. So 1 minus 7, and we have 2 of them, which is negative 6 over 2, which is negative 3. And the absolute value of that is 3. So our distance from 4 to 7 is 3, from 4 to 1 is 3. This is a way to mathematically do it. You can also do it visually. I will take either one with the number line. So we need these 2 points because the way our absolute values are set up is when we set these up, we have our x, and we know it's a greater than or equal to because we are farther away. So what we do is we look at where do we want to be around, and we are going around the point 4. And if you recall from when we did absolute value functions and we graphed them, we did the opposite sign. Well, the same thing works for this when we're doing these inequalities. Since we want to be around 4, this is x minus 4. And then our distance is what goes on the other side of the inequality. Our distance is 3 units, and that goes over here on the right. So now we have the absolute value of x minus 4 is greater than or equal to 3. And this is the absolute value inequality that represents this number line. So again, when you do this, you find the midpoint, what's halfway between the two endpoints, and one of the ways to do it is you add the endpoints together, divide by 2. That's what goes in with the x, because we want to be around 4. And then, since we're going away, we have 2 arrows going out. It's a greater than or equal to symbol on this one. And our distance from 4 to our endpoints is 3. You can just use it visually, or you can use this distance where you take the absolute value of the difference between the endpoints divided by 2. And this is, in this case, was 3. So we have absolute value, x minus 4, is greater than or equal to 3. We do the same thing on the next one. We're going to find our midpoint. And one of the ways to find the midpoint again, you could do it visually, but you could do it mathematically, which is just add the endpoints together, -7 plus 3, and divide by 2. And you get -4 over 2, which is -2. All right, that is our midpoint. So right here is our midpoint. So then either visually or mathematically, you can figure out the distance from the midpoint to an endpoint. And it should be the same both ways. And I'm going to show you the formula way to do it just so you can see it. So if we have -7 minus 3, and we divide that by 2, we take the absolute value, we get -10 over 2. And we take the absolute value of that, which is -5. Absolute value of -5 is 5. So we are 5 units away from -2. We know we're going to have the absolute value. We know that we are less than because we are in between and we have a connected bar, so we are less than. We also know that we are going to be around -2, so we need to put that in here, x, and the opposite sign of -2 is +2, and our distance from there is 5. You'll notice when we do these also that that number on the right side is always a positive number, so there's the absolute value inequality for this number line. Absolute value of x plus 2 is less than 5. And if you ever wanted to solve it, you could set this up and make sure it works. This is 5 units away from -2. So that same idea holds for word problems. It says a company makes boxes of crackers that should weigh 213 grams. A quality control inspector randomly selects boxes to weigh. Any box that varies from the weight by more than 5 grams is sent back. What is the range of allowable weights? So when you're doing these on your homework today too, we are doing absolute values. You need to give me an absolute value inequality and then solve it. So here again, we're looking at what do we want to be around? We want to be around 213. So we're writing our absolute value. What we want to be around, like our graph was the midpoint, we want to be around 213. So it's x minus 213. And the most we can be around is 5. And we want to be within 5 grams, so it's less than or equal to, because we want to be within that distance of 213 grams. So we're going to solve this now. We have x minus 213 is less than or equal to 5. And this is an and. So x minus 213 is greater than or equal to 5, -5. We solve both. We add 213, we add 213. And one thing that's nice about these problems is you should be able to see if you're getting the right answer. So you have x is less than or equal to 218 and x is greater than or equal to 208, which makes sense. So our range is 208 less than or equal to, we'll say x is our box weight, less than or equal to 218. And x is the weight. And if you thought about this, if you have 213 grams, most of you can just look at this saying, I want to be within 5. Well, 213 minus 5 is 208. 213 plus 5 is 218. So you can see if you're getting these right. We do want to have the practice of setting up the absolute value inequalities from the word problem and then solving them, which is what you need to do on your homework. And these are grams. That is absolute value inequalities. So again, this is section 5.5. We just did absolute value inequalities. Make sure you graph whenever it directs you to. Make sure for your word problems you set up the absolute value inequality and then solve to get your range of values. Don't just give me the range. I need to see the absolute value inequalities. I need to see the setup and I need to see the solving. Thank you for watching and have a nice day.